Mics. There is some nuisance. Good morning, everyone. Today we are going to discuss about the sources of contamination. The sources of contamination that arise in the food supply chain, and that if the producers, processors, distributors, or the people engaged or involved in the food business, they won't address them, it would potentially affect the public health. We are going to discuss about the sources of contamination. That is why the sources of contamination that arise in the food supply chain, and that if the producers, processors, distributors, or the people engaged or involved in the food business, they won't address them, it would potentially affect the public health. Since public health is affected, we have to see that no such contaminants, pollutants, toxicants, otherwise what we call them as the food safety hazards, they won't enter the food chain. So that is the requirement. This is what we do this is what we aim at in food safety management systems. So before we can address these food safety hazards, we manage them, mitigate them, minimize them to a level that is acceptable. So let us understand what are all the various sources of such contaminations that arise in the food chain. So before actually going into the different kinds of food safety hazards and their entries into the food supply chain, let us understand the relevance of the food safety. Why we are studying these contaminants, pollutants, toxicants, otherwise the food safety hazards that could enter the food supply chain. So this is the data of World Health Organization. So according to World Health Organization, sufficient amount of safe and nutritious food is the basic requirement for the sustenance of the life on the planet Earth. When we are talking about the public health and the human health, this is of paramount importance. Then only we can expect the good health. Okay. However, the unsafe food, when the food becomes unsafe, when the food safety hazards enter into the food becomes unsafe. Then what are these food safety hazards? These food safety hazards can be broadly categorized into two. One kind of hazards known as the microbial food safety hazards, that includes the various kinds of microorganisms or their toxins, and second is non-microbial food safety hazards. In this, we have got various kinds of chemical residues. What are those? We'll discuss a little later. Of all these infectious agents, the bacteria, the virus, and some parasites, they are of very important, they play an important role when we talk about the food safety. Followed by these biological hazards is the chemical hazards. In addition to this, we have got some physical hazards also. All of them, they say that according to an estimate, there are about 200 diseases that can be transmitted through unsafe food. Means acquiring the disease in the humans, which could be linked to the ingestion of the unsafe food. And the clinical presentation in the human population, it starts from a mild diarrhea, or at times it may go unnoticed to the cancers. That is what is the severity of the, or you can say what you can say, risk associated with the consumption of the unsafe food in the humans. If you just overview the statistics that have been accumulated in the global database, they say that about 600 million people, okay, 600 million if you calculate, 1 in 10 people, means if at all there are 10 persons, 1 person, okay, they fall ill or they get the foodborne disease after eating the contaminated food annually. Okay, of this 600 million people, about 4.2 lakh people, 4 lakh 20,000 precisely, okay, approximately we can say that about 5 lakh people, they die every year due to the consumption of the unsafe food. Okay, if you calculate this, because every time death may not be there, as I told you, the unsafe food consumption would lead to a unnoticeable type of episode to the severe life-threatening disease. That is what is the gradation that is seen in the human being. If we have one yardstick, one scale to calculate such health losses, we call it as DALY, DALY, disability adjusted life years. We'll discuss what is this DALY little later. So they have calculated at the global level. So annual loss is, okay, each year about 33 million DALY are lost due to the consumption of the unsafe food. Okay, if you calculate it in the capital terms or in terms of money, it is about 110 billion US dollars that are lost each year. Why this loss? This loss is due to the loss in the productivity of the individual who suffer from the foodborne disease, or the individuals who spend certain amount of money in the medical treatment. Okay, when they are either hospitalized or they will take some drugs, medicines. Okay, so this is what is the burden is about 110 billion US dollars in low and middle income countries. Low and middle income countries are the developing countries. Okay, we categorize the countries as high income countries, low income countries, and middle income countries. Okay, so these low and middle income countries, they are the one, they are thriving hard for sustenance. Okay, their economies are expanding. So when their economy is in the developing mode, and this loss to the tune of 110 billion US dollars is huge, and which is due to the access to unsafe food. And why food becomes unsafe? Due to introduction of the food safety hazards into the food chain. And what we need to do? We have to see that such hazards won't enter the food chain. Then what are those? That is what is today's class. What are those? And from which point, at which point in the food chain these hazards enter? That's what is the sources of contamination. That's what is today's class is. Just to continue the statistics, at the global level, if you talk about the susceptibility of the populations, one important population which is very much susceptible is the infants and the children. So they have identified that the children under 5 years of age, they carry 40% of the global burden of foodborne diseases. Okay, if you talk about entire population, the population could be from birth to the death of an individual. That's what is the age that we take. And if you take the children under 5, because they often forget to follow the food safety measures, or they are under the learning stage, or they are having certain deficient immune system, they still have to acquire or to get exposed to the antigens in the nature so that they will have the developed immunity. So because of this susceptible window, the children under 5 years of age, they carry almost 40% burden of the foodborne disease across the globe. And if you see the death, okay, 4.2 lakh is the annual death of the entire population. So if you take this death in the children among which are below 5 years of age, 1.25 lakh people, means children, they die every year due to the unsafe food. Okay, that's what is the relevance of the food safety. That's why this topic is very relevant. Just to continue some more statistics. Okay, diarrhea is one of the manifestation of the consumption of the foodborne, this food which is unsafe, or when the food which is unsafe is consumed, that will result in the foodborne disease. And this diarrhea is a consequence of the consumption of the unsafe food. And if you see, due to the consumption of the unsafe food and the water also you have to consider it as food only, because that is also ingested and which is also required for the basic metabolism of the body. So about 550 million people they suffer from foodborne disease every year. Okay, with 2.3 lakh deaths. I am talking about only diarrheal diseases. Okay, when you consume the food, diarrhea is one manifestation. So earlier I talked about in the previous slide, 4.2 lakh deaths every year. This death is due to diarrhea and also other complications including meningitis. Okay, this statistic speaks about only diarrheal disease, the disease associated with diarrhea or gastrointestinal involvement. So 550 million people they suffer, of which 2.3 lakh people they die every year due to consumption of unsafe food. That is why when we talk about in terms of public health protection, so food safety, the nutrition and food security, they are very important for maintaining the positive health of the public health. Because the first and foremost thing is the food security. Food should be available to all. That's what is food security. Okay, and if you take the any strata of this demographic sector of the population, every strata should get or should have access to the sufficient food. That is what is food security. Okay, food should be available in the basket, it should be available in the plate, it should be available in the homes, it should be available in the governments. That's what is food security is. Second comes, mere food is not important. If for bodybuilding, you require nutrients in that. Okay, food which should be available but should be nutritious, should contain nutrients. You know, the micronutrients and macronutrients, both should be available. And the third and the most important is nutrients should be delivered to the consumers or the humans. At the same time, we know that food is produced in the food chain. And when we talk about the food supply chain, there is likelihood of introduction of the hazards. Okay, that is why there is the risk to the public health. So food safety also should be addressed so that the consumers or the people or the public will not suffer from foodborne illnesses. So this is what is food safety. In that context, if you see the food safety, the nutrition and the food security, they are inseparable. They are all linked. Okay, you have to see them as a single entity, or you can say that linked entity, because one is dependent on the other. Okay, next, unsafe food, it is a vicious cycle. Okay, excess which is provided in especially in the low and middle income countries. Why there is unsafe food? Because those countries are resource deficient. Okay, those countries are under development. There are financial constraints to provide the safe food. That is why they are developing. That's why they are low or middle income countries. Since they are poor, they do not have access to the safe food. Okay, why safe food is not available? Because these countries are developing. That's why we say that it's a vicious cycle. And unsafe food and malnourishment, they are also linked. Okay, the country's basic requirement is to provide the food which is expensive Okay, that to provide nutritious, safe food is also it requires many things and is expensive, which they cannot meet. That is why there is malnourishment. Since there is malnourishment, there is higher chance of foodborne disease. Okay, since there is foodborne disease, there is diarrheal disease. That's why there is malnutrition. So they are all intricately related. Okay, affecting these susceptible populations. Okay, earlier I told you, under 5 years of age, they carry the 40% of the global burden of the foodborne disease, especially the susceptible group. When we talk about it, is the infants, young children, geriatrics, and those people having comorbidities. Some other disease they are having, they are now susceptible. After the introduction of the immunosuppressive diseases such as HIV, the epidemiology of the foodborne and the diarrheal diseases also has changed. Okay, that is why when we talk about the foodborne disease, they are hindrance to the socio-economic development of either family or society or the state or the country and the world as a whole. That is why food safety has been increasingly emphasized these days. Okay, it affects every sector. Let it be the HR, human resource related things, let it be the ecotourism related things, let it be the trade related things. Each strata, when we talk about the developing economies, that is affected. Let it be one developed economy also, that is affected. So by and large, foodborne diseases, they affect the growth of a country, growth of the world. That is why we have to address the food safety hazards. That is why we have to understand the various ways and various kinds of hazards that enter in the food supply chain. Okay, next. Today, the food produced by one country is catered to the several countries. Say, for example, a food produced somewhere in the African countries that is supplied across the Europe. The food that is produced in India is supplied in the Middle East. The food that is produced somewhere in America reaches across the world. There is no border for these foods. In the today's, under the WTO design, there is no border. Okay, that is why the food safety hazard entering at one point would cause the effect on the other point. That is why it is very important globally. Just to give some examples, for the agricultural sector growth, Vietnam used heavily these pesticides. And pesticide residue effect was reflected in American population because America used to import the food from Vietnam. Okay, so also some chemical residues that arise in the food of the Africa, it is reflected in the Europe. So when we talk about the globalized food supplies, which is beyond the supranational, many nations involved in the food trade, so it becomes a global issue. Food safety becomes a global issue. That is why we have to work in collaboration. We have to work between the countries. We have to work between the stakeholders, manufacturers, the producers, consumers, all of them. When they work together, we can think of such a food supply chains that will not have food safety hazards. Okay, and let us come to some science here. Okay, so what are these food safety hazards and how they are associated with the illness in the disease? Okay, as I talked earlier, the food safety hazards can be broadly categorized into two: the biological type of hazards, physical type of hazards, and chemical type of hazards. Okay, the physical type of hazards include the dirt, dust, the insects, the contaminants from the environment. These are all the physical types of hazards. In the manufacturing plant, it could be even the metal remnants. Okay, the chemical hazards are various kinds of agrochemicals that are used in the crop protection. Then they enter into the animal body and then they are excreted into the animal product or secreted into the animal product, or they are deposited in the tissues that are edible. So chemical residues, pesticide residues, the antibiotic residues, and the heavy metal residues, etc. Okay. The biological are either foodborne pathogens or their toxins. So when we talk about the foodborne disease illness, okay, disease or illness, it is either due to the physical hazards, the chemical hazards, or biological hazards. Okay, the physical hazards, even you can take radioactive elements also, radioactivity. Okay. So when we talk about the different kinds of foods, you know, there are foods of animal origin, there are foods of plant origin, different kinds of foods. So the entry of these hazards is more or less same. That is why general principles of food hygiene that we discussed previously need to be implemented across the supply chain. Okay. And there have been several attempts globally to quantify the food safety diseases or foodborne illnesses. Okay. So one such effort that was taken by the World Health Organization in collaboration with other concerned agencies in the year 2015. The report of 2015, if you refer to the World Health Organization website, you will have this data. Okay, they identified 31 foodborne agents, okay, as the predominant food safety hazards, because they are the one that are associated with the foodborne disease burden. Okay, burden in the sense the load. Okay. Likewise, one more document in the year 2018. Okay, it is 20 now, 2 years back. World Bank. Okay, they estimated the cost in the low and the middle income countries, the expenditure that is due to the foodborne diseases, it was to the tune of 95.2 billion US dollars annually. Okay, you see that's what is. There are about 7 odd billion people, and if you see this per head, if you calculate what would be the cost associated with such foodborne diseases, the economic burden to the nations, you can just estimate. And for the treatment alone, okay, for the treatment of the foodborne disease alone, there has been an estimated 15 billion US dollars. Okay, that's what is the burden of these foodborne diseases. That is why what we can do, what is expected, and as a veterinary graduates, what society expects from you is that you should take all precautions that these food safety hazards will not enter the supply chain. Okay, the more you prevent, the more you minimize, the more you eliminate, the better societal benefit, human welfare, okay, societal welfare, human well-being, all these things you are contributing through veterinary contributions. This is what is veterinary public health, and this is what we aim at under in the today's context under One Health umbrella. Okay, so with that brief description about the topic that is pertinent here, so let us study today the milk supply chain, the contaminants that enter through the milk supply chain. That's what we'll discuss today. Subsequent classes will talk about the meat supply chain, egg supply chain later. Okay, today's class, okay, I'll just restrict my discussion to milk supply chain. Okay, subsequently other supply foods of animal origin supply chains we'll discuss. Okay. Now, to start with, let us define the milk. So when I say milk, be clear in the mind. I do not mean elephant milk. I do not mean dog milk. I do not mean the tiger milk or the human milk. I won't mean that. Okay. When I mean a milk here, I mean the market milk. Okay, what is market milk? The milk which is available as a food in the food supply stores. It is available in the retail market. It is available in the wholesale market. It is there in the trade. This is what such a food commodity. Regarding that, I am talking about as a milk. I am not talking some plant secretion which is milky like. We call it as a milk. Okay, I am not talking about the species milk which is meant for the nourishment of the animals. Okay, that's not the milk here. Then you may ask again the next question. Sir, then if not, then from where you are getting milk? Are you getting milk from a machine? No, I do not mean that. Okay, after all, it is that one only. But we have engineered over a period of time the milk producing animals udder to be a factory. Okay, something like a factory that has been over a, it is due to the consequent, what you can say, constant efforts of our geneticists, our management people. We have engineered the udder to produce, instead of half liter or 1 liter of milk, to 70 liters or even a record 100 odd liters milk. Okay, that has been engineering of the udder. Okay, over a period of time. That has been done. This engineering is not a genetic manipulation. It is upgradation, improvement, selection. Because of these things, we could exploit these milk producing permitted animals. Okay, that's why I'm telling you. If you bring a elephant milk and say, sir, this is milk, that is not permitted legally. Okay, then what is this milk? The milk predominantly of a cattle, buffalo, camel, yak, sometimes today's the market donkey, sheep and goat. This milk we call it as a market milk. A species milk which is permitted, just like meat definition. You know, what is milk to me in this course? Meat to me is ruminant meat, barring those species that are specified under Wildlife Protection Act 1972, barring those that our society won't accept that as a flesh. Cockroach I cannot offer it as a scorpion I can offer in India as a meat, okay, which is not permitted. So there are certain species that have been specifically recommended to be slaughtered and to be consumed legally. So that's what we call it as a market meat. Okay, if you bring a deer meat, then immediately you are put under bars. Okay, anybody consumes or involves in the sale of deer meat, that's not applicable. Our principles are not applicable to deer meat. Our principles are not applied to the carnivorous meats. In omnivore, we have only pig. Okay. So likewise, in that context, when we talk about the milk, so milk is market milk, whole. Each word is very important here. Write down very carefully. Whole, fresh, clean, lacteal secretion. Okay, you have to milk the cow whole. Means a cow is giving 4 liters of milk. Means you have to milk that all the 4 liters. That's what is whole. You cannot take initial 1 liter. I will take, sir. Remaining I will leave. No. Whole, fresh. Like it has to be immediately drawn. It should not be drawn 2 days back and kept in the fridge and now I want to say this as a milk. No. Then you may ask a question, sir, milk packet they store no for some hours in the, that is different. That is processing. Okay. Whole, fresh, clean. Clean means clean milk production practices applied. The milk should be milk only. It should not have the remnants of the chopped fodder from the manger. It should not have hairs from the animal while milking. It should not have the flakes of the dung. It should not be mixed with the urine. Okay, clean. Clean means it should be free from all those extraneous, external dirt, dust, insect, whatnot, vermin, etc. Next, lacteal secretion. Lacteal secretion means you know that mammals have a special capacity during the evolution. Okay, you know, in development of the egg, you know, egg has a egg laying animals. They have different kinds of things. Okay, so here even after the birth, to nourish the young one, for the mammals, the nature has bestowed or gifted this milk. okay, for the nourishment of the young one. Okay, that's why we call it as a lacteal secretion, means the secretion that comes from the glandular tissue in the udder. We call this as udder. Okay, udder and glandular tissues is located. From blood, certain nutrients are filtered and we get a whitish colored secretion. We call it as the lacteal secretion. Even some plants also, they yield certain lacteal secretion that also has a commercial value. That is not a milk. Soybean, if you mix it with the water, that becomes a whitish colored solution. That is not a milk. Okay, so here what I mean milk here is whole, fresh, clean lacteal secretion obtained by the complete milking of. You see again, complete milking, whole and complete I told you earlier. Okay, whole in other contexts also. Whole means the milk contains fat, SNF, other things. No fractionation should be done. However, there is a standardization process regarding that. I'll talk a little later. Okay, it should be complete as a whole, wholesome. Okay, and complete milking means complete process of milking of one or more healthy milk animals. Healthy. Okay, underline this. Healthy means animals should be free from brucellosis. Animals should be free from tuberculosis, other communicable and infectious diseases. It should not be. It should be healthy. It should not be fevered. It should not be suffering from diarrheal disease, etc., etc. It should be healthy. When we say an animal to be healthy, when it is not diseased. Okay. When you say that it is not diseased, there are no signs and symptoms indicative of a disease. An animal is performing all physiological functions normally. Such an animal is called as a healthy animal. And this milch animal is, again, underline the milch animal. Tiger is not a milch animal. Elephant is not a milch animal. Okay, one or more healthy milch animal. Okay, only milch animal you have to milk. Okay, and it should conform to these terms that I talked earlier. And now you see the further, excluding that obtained within 15 days before or 5 days after calving. What is this? This is a window period wherein the composition of the milk is totally different. Okay, if you take such a milk, either your pasteurizer gets clogged, okay, or your entire milk's composition would change. That is why we do not want this secretion. Okay, 5 days after the milk, you call it as a colostrum. Okay, this colostrum should not be. This colostrum is not a milk. Even though it is a lacteal secretion, colostrum is not a milk for my market milk definition. It is meant for the young one, you offer it to the young one. Okay, after the young one is happy with the milk, okay, nourishment is met, extra you do some other product, that's not an issue. Okay, sell it as colostrum, but not as a milk. Okay, 15 days before calving. So we, in animal husbandry practice, we follow a 60 days drying period now. Okay, just before parturition, so that animal will gain the body strength metabolically, so that it will give milk for 305 days. Okay, whatever it is. So that is why there is a drying process and all that, this dry period. Okay, so 15 days before calving or 5 days after calving should not be, that secretion should not be included as a milk. Okay, and it should contain minimum prescribed percentages of milk fat and milk solids not fat. This is a commercial aspect. Until colostrum free is a physiological aspect. Okay, you cannot engineer the udder to produce more calcium or to produce more vitamin. You can alter the diet. Okay, you can alter the diet, but you cannot genetically engineer the udder tissue. That's not permitted. Okay, so that's one point. You please keep it in mind. Second thing is that here I am telling, once the milking process is over, I have mixed one or more animals, healthy animals, milk together. Now after this, so in a milk processing plant, trade issue. Trade issue means to deliver constantly the required proximate composition. Okay, what I will do, if the milk that is having more fat, I will remove certain fat. Okay, and if at all some milk that is having less fat, I will introduce into that. So I will standardize the milk, this the fat and solid not fat, using certain machines, so that consumers are delivered with a constant fat and solid not fat. These are the two parameters in the milk which are of commercial value. That is why this definition is a market milk. Okay, and what is this? How much fat should be there? How much solid not fat will be there? This will be dealt in detail by LPT. Okay, there are different grades of market milk. Okay, you know there is one toned milk, double toned milk, single toned milk, so whole milk. So these are various categories of the milk. These have been recommended by the suitable government agencies. Okay, 1.5 fat, SNF, 8.5 SNF, or 3% fat, 9% SNF, whatever it is, these are specified by the governments. Accordingly, that grade of milk is marketed in the market. So this is in nutshell what the milk is. Anything other than the natural composition of the milk, or other than standardizations with respect to fat or milk solid which is not fat, SNF, so no other manipulations need to be done when we talk about the market milk. Okay, whole milk I am talking about, raw milk. If it has to be a product, other standards apply. If it is a butter, if it is a ghee, if it is a paneer, if it is some other product, the other specifications they apply. But whatever may be the product that is manufactured in the plant, the basic ingredient is the milk. Okay, we will discuss about the contaminants that enter, or sources of contaminants, sources of contamination that are expected in the milk supply chain. Okay. Now you see, this is what is the udder. Okay, in the udder there are alveoli, milk secreting the tissue. Okay, and there is from the blood, these nutrients are poured into the glandular tissue. Okay, from lumen through duct system, through the gland cistern, to the teat cistern, to the streak canal, then into the tail. Okay, the bucket, the milking utensil, the milk comes out. This is the process. There is a lot of anatomy involved, lot of physiology involved, lot of biochemical processes that occur here. All this has been dealt sufficiently. In this BPH course, I will deal with only contaminants. Okay, I will deal with only the food safety hazards. Okay, remaining as a student, as a veterinary graduate, it is your duty to understand the physiology, the biochemistry, and anatomy of milk production and the structures associated with the milk synthesis, storage, or until the secretion. Okay. So milk is a natural liquid product that contains the nutrients meant for healthy living, healthful living. And at the glandular part, okay, at its glandular part, when it is secreted, it has to pass through the blood mammary gland barrier. So it is a type of filtration mechanism, because nutrients are through biochemical process they are produced. So when milk is synthesized and it is secreted in the glandular tissue, from the glandular tissue, okay, that is sterile. However, soon after its secretion, the organisms that have entered through the teat canal, into the teat cistern, into the glandular cistern, and then into the duct system, okay, up to the alveoli, okay, this is what is from the reversal end, okay, or sometimes hematogenous spread. Okay, you know that the blood mammary gland barrier will not permit. But if it is an invasion, okay, if some organism pores, drills hole and then comes out, you can't do anything. Okay, if it is through a natural process, organisms cannot, because it is a filtration through the cellular filtration. But if the organism makes a holes or creates a pusculous tract, nothing can be done. So whether it is heterogeneous or through exogenous, the organisms, certain organisms are inhabitants of this other tissue. Okay, many are good bacteria. Many are good bacteria. Occasionally, some are bad bacteria, and these occasional bad bacteria are associated with the disease. And these good bacteria, so as long as they were in the udder, so long okay. And when they have come out in the collected milk, okay, from a milking animal, so there they lead to deleterious changes in the milk. We call such milk as a spoiled milk. Okay, when there is proteolysis, whenever there is a lipolysis, the saccharolysis, we call such a milk as a spoiled milk. So they may not cause the disease in the humans, but it is associated with the spoilage. So these organisms, which are natural inhabitants or normal inhabitants of the adult tissue, they are also important public health point of view. Okay, pathogens, of course, they are associated with the disease, infection, or intoxication in the human consumers. Okay, so milk is if I ask a question, when a milk is collected from the teat of a udder, udder of a milking animal, is it sterile? Your answer should be no. Okay, it is only of academic importance to understand or to know the milk is sterile when it is synthesized and secreted in the duct from the glandular tissue. Then it is sterile. When it is collected here from the teat, if you try to isolate several genera of microorganisms, especially bacteria, you can isolate from the milk that is collected from a cow, healthy cow. Okay. They may not be pathogens. Okay, if pathogens have entered here or have come from the hematogenous route, then pathogens will be isolated. In the absence of pathogen also, the normal inhabitants will be there in the milk, and they will leave a symbiotic relationship, no? Symbiosis. Okay, you know what is symbiosis. Okay, udder is also not much harmed, and the organism is also not killed. That's what is like that. They will survive in the udder. Next, the various kinds of contaminants, they enter into the milk either during number one is in the milk itself, glandular milk udder itself. Second is during milking process, during milk handling process, during milk storage process, and pre-processing. Okay, at all these points, the contaminants, they enter into the milk, because no cow will secrete E. coli. No cow will secrete the Staphylococcus aureus, but these pathogens have entered there. Since they have entered there from the exogenous source, they are likely to cause foodborne disease in the human consumers if the milk is consumed boiled, unboiled, or raw. Then, so as a custodian of the food safety, you as a veterinarian, it is your responsibility to keep the food chain, supply chains, here it is milk supply chains, free from such contaminating agents. We call them as food safety hazards. Okay. And what is this contamination? Contamination can be categorized into two types. One is intentional. Okay. Second is accidental. Okay. Incidental, accidental. Accidental means you don't mean that. You don't want to introduce any pathogen or contaminant into the food. But while milking process, they have entered through air. They have entered through the outer surface of the teat. They have entered through the milking pail, through the hands. Okay, accidentally they have entered. Second is the intentional addition. Intentional addition means milk has been adulterated with the water, and water is containing E. coli. Okay, that is knowingly introducing. So Whether the organisms enter through accidental or incidental pathway, ultimately it is going to harm the consumers. So when we talk about the global trade, okay, they are taken as potential barriers to the trade. Okay, we'll discuss that later. Okay, so these contaminants can be broadly categorized as either microbial contaminants or non-microbial contaminants. Okay, non-microbial is mostly chemical or physical. So microbial is mostly biological. And when we talk about microbial, either it is the organism themselves or their toxins. And the sources could be endogenous or exogenous. This is with respect to animal and the other. Endogenous in the sense, say for example, animal is suffered from tuberculosis, mammary tuberculosis. Okay, tubercles are formed in the mammary gland. So tubercle bacilli, obviously they are secreted into the milk. The source is endogenous. Okay, or the brucella organisms have localized in the glandular tissue of the udder, and milk contains the brucella organisms, endogenous. Okay, organisms are there in the cow body itself. Okay, in the udder itself, either cow body or in the udder, endogenous. Exogenous in the sense, milk pail is contaminated, bucket is contaminated, okay, or there is buildup of the microorganisms. Okay, that's what is exogenous. Or through the air, contaminated air, dusty air, the organism is entering into the milk. Okay, at the process, which process? Milking process, or during transportation, or during processing, we call this as exogenous. Endogenous, exogenous. Endogenous within the cow body up to teat canal. Okay, exogenous anything outside. Then interior and exterior of the udder. So this is related to udder. Udder is the focal point here. Udder in the sense, anything which is within the udder is interior. Anything which is external to the udder is external. So based on the source from where the contaminant is entering, so we can call the source as endogenous or exogenous, interior or exterior of the udder. So you can see, okay, various kinds of microorganisms. You can see the potential sources of mammary microbiota. Okay, they could be from the bedding material, they could be from milking equipment, milker's hand, flies, or through the cross contamination they will enter. And various kinds of these microorganisms they can enter. Even the physicochemical contaminants also, they are likely to enter later on once the milk is collected. Okay, if at all the chemical residues, they can come through the cow ingestion, then hematogenous, then from blood they are secreted into milk. That is a pathway. Okay, but this diagram indicates the microbiota. It's only microbial one. The various kinds of firmicutes, the actinobacteria, the bacteroidetes, okay, the proteobacteria and other kinds of bacteria if you see. So they all can enter. So majority are the firmicutes. Firmicutes, when you talk about the Staphylococcus, Enterococcus, the Clostridials, the Aeromonas, etc. Okay, they are the sources. Regarding this, we'll study some other time. Okay. So when we talk about the introduction of such food safety hazards, several factors, let it be the udder homeostasis, or let it be the managemental practices, let it be the cow-related factors, or the microbial factors, they all influence the introduction of the food safety hazards into the milk. Okay, and these organisms they enter at various stages of the milk production. Let it be the cow itself, or through the barn, or the contaminated air during milking process from the milker. So these organic contaminants they will enter even thereafter also until it reaches the consumer's mouth, domestic supplies. Okay, they can enter. Okay, milk production at the farm level or in the cans, bulk coolers, chilling centers, the milk plants. So what we have to do? We have to follow the hygienic or sanitary measures across the milk supply chain. That is what is need of the hour. Okay, you can see from soil, feed and fodder to the water, they can enter the milk. Okay, various extraneous sources. Okay, the milking equipments, the logistics, during logistics, milk processing plant, everywhere they can enter. So the milk contamination that occurs at the farm level, they are either non-microbial contaminants such as physical, dirt, dust, the insects, etc., or chemical contaminants such as veterinary drugs, the sanitizing agents, the agrochemicals, they are the one, or the pest contaminants, okay, or the environmental contaminants, various kinds of sprays and all, okay, cleaning and disinfection related substances, okay, that are used in the dairy farm. The microbial contaminants include contamination occurring by pathogenic bacteria, various kinds of bacteria that we'll discuss little later, okay, during milking, okay, if the animals are the carriers, or if the animal is suffering from the udder inflammation, that you call it as mastitis, or human handler means milker suffering from some the infections, or through the environment air is contaminated, so they all could be introduced into the milk. Okay, in addition to this, fecal contamination means, you know, that udder location is which is very much near to the excretory system outlet and digestive system outlet, so they could be introduced into the udder if hygienic measures are not followed properly. Contamination occurring due to environmental organisms, as I told you, they are there in the air, suspended, floating, uh, they can get access into the milk during the milking process or thereafter also. And these microorganisms, they multiply, you know, the generation interval of these bacteria is 20 minutes or less than that. So they will expand in their number, so leading to the spoilage of the product. It is not a pathogen. If it is a pathogen, that would lead to foodborne disease. Milk collection center, different supplies, when they are kept side by side, there could be cross contamination. The people who are handling the milk, they can also contaminate, so environmental contamination can also occur. So these are the sources of contamination at the milk collection center. During the transportation, if the interior of the receptacle is not clean, okay, there is built up of the microorganisms, so that would potentially contaminate the supply chain. So like this, the various kinds of contaminants, they enter into the milk supply chain. Okay, so let us end today's class here. So remaining things we'll discuss in the next class.